Well, hello everyone. Welcome to our webinar, Introduction to Coreform Qubit. We're happy to have you join us today. My name is Kimberly White. I am Chief of Staff here at Coreform. Our presenter today is Greg Vernon. He's the Director of Product Development at Coreform, and he is a Qubit power user. Also joining us on the panel are experts Mark Richardson and Carl Merkley. If you have a question at any point in this webinar, you can go to the Q&A tab at the bottom of your screen. It's sort of center left on your screen. You can ask your question there, and Carl or Mark will answer it for you. The full text of the Q&A will also be available to everyone after this webinar. So our agenda today is to give you an introduction to Coreform, and then Coreform Qubit. We'll have a summary, and then we'll take time at the end for you to ask questions. So Coreform is based in the lovely Silicon Valley of the West in Orem, Utah. We developed Coreform Qubit, which is the commercial version of Sandia National Labs Qubit. We are also developing isogeometric analysis technology, which you can learn more about on our website. And on our YouTube channel. So we have all of our webinars and some other videos on our YouTube channel. We have a growing collection of videos here, and they're for you. So if you ever have any feedback or suggestions for new content that you'd like to see, you can email me directly. And you can find my address in the email that you received when you signed up for this webinar. And finally, we have Coreform Qubit Learn, which is a version of Qubit. It's a full version of Qubit available to anyone who is using it for non-commercial use, students, hobbyists, anyone, any non-commercial user. And it's the full version with just an export limit. You can find that also on our website at coreform.com. And we welcome all of you to give it a try. Now, before we begin, we'd just like to take a quick poll, which you'll see pop up on your screen. If you could please answer this really quickly, just to help Greg as he proceeds with the webinar to know what level of experience everyone has and how we can kind of direct his work. We'll let this go for a minute to give everyone a chance to vote. Looks like a lot of you have never even used Qubit before. That's great, you're in the right place. Let's give it just a few more seconds. Okay, thank you very much, all of you, for helping us with that. Looks like we are a relatively inexperienced group, at least with Qubit.
Yep.
There you go.
Yeah, good. This is hopefully exactly the webinar that those of you who haven't seen or haven't really used Qubit or don't have a lot of experience with it, this is the right place to be. And I hope that even some of the power users, I think that there is even stuff today that you'll find that will be helpful for you. And so I hope that this does kind of scratch everyone's itch today.
Well, with that, Greg, let's begin.
All right. Yeah, so thanks everyone for joining today. I'm going to take just kind of the approach today. I'm just going to kind of dive in and just give some live demos of using Qubit, and just to kind of give some idea about what is like the philosophy behind Qubit, and how do you build workflows, and how do you build meshes using Qubit. And so I'm actually just going to hop out of the presentation, out of PowerPoint, and just dive into Qubit. So this is the GUI for Qubit. And one of the things you'll kind of notice just in general is that we have a command line box. These things are dockable and undockable. So all of these little boxes are dockable and undockable. And so there's command line, there's some Python command lines that you can do as well with tabs. We also use a command panel, which gives you a graphical interface to then doing things like meshing or modifying geometry in Qubit. So we'll be working on this heavily today, as well as other tabs like some power tools. So some of you may see some tutorials that dive into using power tools to help you in your do certain operations, as well as maybe for a lot of you folks, you might even be interested in starting with this item command panel that kind of walks you through the steps to building and exporting a mesh. We have a model tree so that you can make queries and see what you've built in your current session. And then for certain objects, then we have properties page, which gives you a quick overview of things that are specified on a given entity inside of Qubit, whether in this case it's a volume, or if it's a surface or curves, or if you got meshes you want to query. The properties page gives you a lot of information there and some quick actions. If you ever remove one of these panels, so if I've accidentally come through, maybe I've come through and I've removed all of these panels, and I'm just left with the render window and I'm wondering where things are. Our view in the menu bar allows you to then activate or deactivate these through here. So sometimes you have to come, you might find yourself coming back through to set up Qubit just the way that you want for your current session. Also, something that's useful to know is our options to modify the Qubit kind of session. So you can do things like change the command panels. So one of these we're going to see today is this navigation hierarchy in the command panel. You notice that there's a checkbox for classic hierarchy or kind of a new hierarchy. And the classic is to go by entity. So if we look here in the command panel, it starts with mode and then entity and then an action. So you kind of navigate from top down to the bottom. If we do the new mode, which is not classic, you'll notice that now instead of going mode, entity, action, it goes mode, action, entity. So just to give a quick demo of the difference there, is that I can create a new cylinder, say, of height 1, radius 1. So I've gone mode geometry, entity is a volume, action is create, and then I'm choosing cylinder. In the new mode, you would go mode geometry, operation create, and then you would choose create a volume cylinder. And depending on your workflow, you might choose that you like one of those kind of workflows more than the other. But with both of those workflows, there is an option that's new to use a breadcrumb trail, which can save you some of this vertical space. And so you'll see now this hierarchy has been pulled into kind of a bit of a more compact form, that as I click through create geometry volumes, I'm not getting like this cascade. This can be particularly useful if you're on low resolution monitors and you're just kind of like crammed for space, and you need a solution there. So I don't particularly use the breadcrumb trail on my desktop computer because I've got really large monitors. But when I'm on my laptop, I find that I like to use breadcrumbs so that I can retain some of the space in my command. So today I'm going to use the classic hierarchy, and I'm not going to use breadcrumbs so that you can see the actions that I'm doing. Another thing that we offer or provide in Qubit is a journal editor, which you can access either through Tools Journal Editor or through clicking this icon for Journal Editor. And what you'll find, or what we find, is that as users become power users, they start to move away from just using the command panels and using the GUI to beginning to use commands to operate Qubit. And then they start to automate their processes or store the processes that they've done as commands in a journal file or in a We also offer Python for journaling. And a little bit of perspective around this, Qubit was developed in the 1980s, and the people that were, the FEA analysts, finite element analysts, prior to them, it's like I had an old mentor. I guess I shouldn't say he's that old, but I had a mentor who they were building meshes by hand, on like pen and paper almost. And so for them, it was a huge jump to be able to say, well, now I can build a triangle mesh by just sending a command to say mesh the surface, and then use like a Delaunay triangulation or advancing front to mesh a surface rather than drawing it out by hand. And so Qubit started as a command language, almost like a programming language, kind of that accelerated those people's workflows. And it wasn't until many years later, actually, I think it was, Carl may have to correct me if I'm wrong, I think it was the late 90s, where they finally added a GUI to Qubit to allow, democratization of using Qubit to more people and to accelerate their workflows. So Qubit is very much still, our philosophy is everything in Qubit is a command. It can be written as a command, and we develop new functionalities as commands first before then adding GUI-based workflows around them. So we really try to focus on having sensible commands. And so what you'll see with Qubit is that as we're going through and building a model, we actually will journal all of the commands you've done in your session into history, which you can then copy from and put into a journal file, or you can just issue the commands manually through the command line. So today, I'm going to do most of these demos through the command panel, but I'm going to show you then we're getting these commands through our journal file. So without further ado, I'd like to just start showing how to build meshes in Qubit. So I'm going to import some geometry. I'll mention too that I'm going to also give a demonstration of using Qubit to build a mesh that we can then run in some open source codes. So I'm going to show Firebreak today. So I'm going to start with this example, which is, you can find this example in the examples that we provide on our webpage, on our tutorials page. There's some downloads. I'll show that at the end of the webinar today. I'll show you where you can find these at. So with this geometry, one of the first things we might oftentimes want to do is check to see if this geometry needs any healing done to it. So that's probably an issue with CAD, that CAD is designed or built for designers and for production engineers, and so maybe it wasn't designed with simulation in mind. And so sometimes you need to heal a geometry. So we can choose, so I'm on Mode, Geometry, Entity, Modify, Heal. If I right-click in this pick widget box, I can select all, and that'll type in this all for all volumes. I'm going to analyze them. And this is great. This volume is perfect in terms of, from a healing standpoint, the geometry doesn't have any invalid surfaces. It's not imprecise. It's good for us to work on. Now, Qubit works on this idea of doing web cutting to decompose to hexes. When we do web cuts, to show just an example of our web cutting, if I go to Geometry, Volume, Entity, let's do a brick that's 10 by 10. We could either mesh this volume right now, or we could also decompose it. Maybe I want to decompose this geometry with maybe some offset here. Maybe I'll do this offset like 2.3. In some meshing programs, partitioning leaves these volumes joined. In Qubit, we think of web cuts, I mean, it's a scissors icon. It really does cut the geometry. So I could actually move this volume and it's completely disconnected, as you can see. So that's something to be aware of that as you do web cuts, you're decomposing geometry, but they're no longer connected. And so these volumes, if you mesh them independently, the meshes are also disconnected. We sometimes call this non-conforming. These meshes don't conform. They don't share nodes. And so we'll show in Qubit in a little bit how, if you want to have meshes that are joined together, or conforming meshes, that there's a process that we do in Qubit to do that. So I'm going to go back and re-import this other example though. One of the things that's common in analyses is to defeature geometry. And Qubit does offer defeaturing. So through our mode geometry, we can remove these fillets. So that's a surface operation. We're going to modify surfaces, and we're going to remove. And so I might choose to remove this fillet, as well as these small fillets here. These are going to drive really small mesh sizes if I leave them in. And they're maybe not important to the actual simulation that I care about. I've selected multiple surfaces by holding down the control button on my Windows machine and then selecting multiple surfaces. And if I do this operation by clicking apply, you can see that those surfaces have gone away. And notice again that in our command line, we've been journaling these commands. You can see this in our history as well. And as a power user, what I oftentimes will do is I'll be copying these commands and placing them into a journal file for repeatability. And so what I can actually do here is I can actually play this journal file, reload my model, and re-execute those commands. Something else to note is we'll show an issue here that there's some overlap between my geometry. And I'd like to show you what that results in a little bit, and how to fix that. So in Qubit, I talked a little bit about this conforming mesh and non-conforming mesh. In Qubit, when you want to then bring things back together, we need to merge objects, merge their shared surfaces. What that kind of means is that we actually need to create these merged surfaces, or these mergeable or duplicate surfaces. So if I actually draw these two volumes together, I selected them both, right-clicked, and then selected draw to just draw those two volumes. If we draw now just this green volume, you can see that it's not going to have any surface that is a duplicate of that purple surface, or that purple volume. And so what we're going to do is we're actually going to imprint that purple volume onto the green volume. So let me redraw that other volume. So if I do this imprint, that's a mode geometry, volume, imprint. Let's just do imprint here. Let's merge volume 3 and volume 1. What you'll see now is if we draw the green volume, it now has a curve that it imprinted from that purple volume. And it split that
Greg?
original surface. Yeah,
We have a question
sure.
about the auto check. So the question is, the auto check healing on the geometry, does it or does it not detect overlapping regions? Or was the overlap just an artifact of removing the surface?
Yeah, so the auto check does not. There is options in item, or I think it's a power tool, to look for overlapping surfaces. So I'm going to show that in a little bit. There's a volume overlap. But what I want to show is what the problem is if you don't clear out these overlaps, this imprint has now imprinted this really small little feature in this domain, as well as you've got two volumes that consume that same space. And so it's maybe not even physical at this point. If we were to mesh this volume, I'll just get to this mesh here. Let's let me cut this volume just to show like what the issue is with these overlaps. I'll explain what I've done here later, but just to see this issue. I were to mesh this, imprint these two volumes now together, and then merge them, you can see I've got this really bad element in this cyan volume because it's trying to respect the fact that there's a really small surface here and a small node here. And so you'll oftentimes will see this. And there's also a really thin, and select this element here actually. There's also a really thin element here. So I've gotten now out several bad elements because of that overlap. So that's one issue with overlaps. They cause bad meshes, but also they're maybe not physical. If you've got maybe steel for one volume and then air for the other, you've got like an overlap of materials. So to show how we can detect that automatically, so I'm going to just open up my journal file again and play to recover where I had been. With this power tools under geometry, I can then select multiple things for it to check, including volume overlaps. And then, so I've selected those options, right? So I came into options, selected the volume overlaps, clicked done. I can now analyze the volumes. And actually, this overlap, we can see here, it's found between volumes 1 and 3. So for all of these, I've got these different kind of warnings it's giving me, but specifically for these two volumes, I've got this overlap. And I can draw this volume overlap by right-clicking on this this pair. I can draw the volume overlap, and then we can see that there's this little region that's been overlapped. And so that gives me a hint that I might, I'm going to want to fix that. We do offer then in the power tools some features to then clean up geometry. What I'm going to do is I'm going to show actually cleaning that through the command panel. So I'm going to right click in my display and hit refresh. There is a Boolean operation. So Boolean operation icon here. So geometry, volume, Booleans. Remove overlap. And I can select these two volumes and then choose which volume I want to remove the overlap from. So maybe I want to remove the overlap from the larger of those two volumes, or I can manually specify one of those volumes. Let me just use it again. Maybe I want to remove it from the green volume specifically, or that pink volume. And if we zoom in now, you'll see that that overlap is gone. So that's another example of things that you want to clean, heal up with your geometry Qubit that you can do. Now we want to make this hex meshable. And to do that, we have these commands for web cutting. Something that I like to do before I go through and web cut is to assign groups or regions for the different parts. And so I might go ahead and create like a group. Call this like, I call it the maybe a pin, and maybe another group for a seal, and another group for housing. And then select volumes, right click on them, add them to a group. I'm going to add this to the pin group. I'll select the purple volume, add it to the seal group, and select the yellow volume and add it to the housing group. Again, along the way, these have been adding these commands. I'm going to copy these commands again and paste them into my journal file. By the way, the pound sign or hashtag is a comment in Qubit's command language. So I can say create groups here, and this will give me, will allow me to comment my journaling. Try to be like clean up geometry. So I've got these groups and I want to now do decomposition. And the question is, why do we do decomposition to build hex meshes? So I want to give just some background for why we do this. I'm going to open up a geometry here and just talk about the meshing challenge. So Qubit is a world-class hex meshing tool, but it also provides tetrahedral meshing and triangle meshing and hybrid meshing. With triangle meshing, it's a solved problem, or with tetrahedral meshing, it's a solved problem to have all surfaces mesh with triangles. And then from this triangle mesh, I've only meshed the surfaces here. There are no tetrahedra in this model yet. You can simply build a tet mesh from those triangles without having to update the triangulation. That's a solved problem for tetrahedral meshing. Just generate any valid triangle mesh, and you are guaranteed to be able to build a tetrahedral mesh. The problem with hex meshing, I'll even just show these. Show these tetrahedra. Right, so I've now got a volume mesh of tetrahedra. The problem with hex meshing, I delete my mesh and refresh here, is that if I start with a arbitrary quad mesh on my surfaces, it's an unsolved problem in mathematics to build a hexahedral mesh from an arbitrary quadrangulation like this. We don't know how to build hex meshes on this. And so we're using Qubit to turn our complex geometries into subregions that can individually be hex meshed through internal algorithms that build hex meshes on certain geometries. And then we can compose those together into a global mesh. So in this case, it's clear that this geometry is mappable to a cube. And so we can assign a volume mesh scheme called map, which essentially maps a mesh to a cube, or maps a mesh to a cube here. So I built now a mapped mesh. Qubit knows how to take this geometry and apply a mapped mesh scheme. Qubit also knows how to take any given surface. So if you have a pair of surfaces, I can sweep this surface to another surface along other surfaces. So I can define a sweep definition. So again, here I'm just been in mesh. I did a surface mesh by going mesh, surface, scheme, and then pave. I'm going to now create a swept mesh through mesh, entity, mesh, mesh scheme, and sweep. Sweep this volume from this source surface to this target surface. And notice how, it's telling me even down here in the bottom that I've now assigned this volume a sweep scheme. We see it over in our property page. Now this is now a meshed volume. And so the trick in Qubit, or with hex meshing, is to take some complex geometry like this and to break it down into subregions that are individually hex meshable with the given algorithms in Qubit. And so let's go through and let's actually build a hex mesh on this geometry.
Greg, we have a question.
Yeah.
And if you're planning to address it, just let us know. But we have a question about the ability in Qubit to create finer meshes near boundaries, for example, where you need more precise resolution.
Yep. Yeah, that's a great question. Well, I'll show that in this. I wasn't planning to, but that's easy to show. Let me show that in this example. So what I'm going to do first is we can kind of see that this little top surface here, I could chop it off and I would get like a rectangle. And then if I chop off this cylinder feature, I'd have an annulus, which is mappable to a cube. And then I could sweep from this surface to this other surface. And so I've kind of like mentally broken this down already for how I'm going to do this cutting. So let's do these cuts: geometry, volume, web cut. I can choose a plane surface for my web cut. I cut volume 2 with this plane. I can preview this cut to make sure what I'm cutting and how it's doing the cut. You can see now this region here is just a prism. I can then cut this volume again from a plane. Actually, yeah, let's do it from a plane. I can chop off this bottom region. And so it's an annulus. Through imprinting, I could have a conforming mesh. What I find oftentimes is useful to do for regions that are really blocky like this, sometimes I like even doing another cut. I'm going to cut this gray volume by extending the surface of this blue volume. I can preview this cut, so it's going to be a cylinder cutting through the gray. And I can then cut this volume as well by extending its outer surface. I can do similar cuts for this gray or for this green volume. I'm going to isolate it by itself, so I can right-click on it, and I can isolate this volume. Extend its surface, and then I'm going to cut with planes this inner volume here. So I can choose this volume or that surface to do the cut with, and I can choose this surface to do the cut with. And again, I've got all of these commands that have been journaled. So I'm going to copy these commands again. Might say this is now decompose for meshing. These commands where I did a preview, I know that I can delete these because these are just previewing the cut that I had done. And then draw all the volumes again, or I can refresh my display. So one of the things you've seen here is in my model tree, when I did that locate, it actually turned off the visibility for some of my volumes. We can just select those volumes and then turn their visibility back to on. And we can see them all again. Now I want to build a body fitted, I want to build a conforming hex mesh. So what we do here is that some of these volumes have not, you're right, we haven't cut this blue volume to match this yellow, so we do need to imprint this volume. Like I'm just going to imprint all the volumes with each other. You know, again, that has passed some of this topology information. If we look at this gray volume, for instance, right? Those little blocky features are now imprinted onto it. And I can then merge all these volumes together as well. And so you can see it told me that I've merged 13 pairs of surfaces. We can actually even draw. So there are some advanced tutorials that we have that talk about our extended commands, but I can just draw surface with this flag is merged. So we can now see that these are all of the merged surfaces. So I'm going to have conforming meshes across those interfaces. And then if we can mesh these volumes, we can specify the meshes manually if we want. We can also try to see if we can get lucky. And I can select all volumes. I'm turning on X-ray selection, hold down Control, and then click and drag, select all volumes, right click, and I can mesh. And so Qubit has automatically come through and it's assigned automatically schemes to these volumes. If I want to change those, I can. So it's selected like some sweep surfaces. We can go through and we can manually select for some of these, but I just want to show that this is now a conforming mesh that we built. There's a question about being able to specify like creating a finer mesh in some regions. Just for ease of viewing, I'm going to change the color of this volume. It's kind of a neat little feature. If I select this volume and go into its properties page, I can give it a different color. So maybe I want to give this color, maybe like this light pink, with a little bit easier for us to see the mesh on it. So where we might have gone through Qubit and specified like a size for this volume through the command line, or sorry, through this sizing action. So I might have chosen like an automatic size to be super fine. You can also specify sizes on a mesh. or sorry, on a surface. So I could say maybe I want a certain surface to be a certain size. So I might choose this surface. I want this to be size 0.05, which is clearly a pretty tight mesh here. But then that will then drive the refinement that this surface would have, right? Its surfaces would have. Oops, did I stop sharing? Oh, okay. Or we can also specify sizing on curves. So maybe on this example, I want a fine mesh near the middle and a coarser mesh on the outside. I can select this surface. I can do a biased mesh. You can choose like intervals and bias. I've got preview on, so these little blue dots are showing me what my mesh is going to look like. I can change the bias factor here. Maybe I want to have 10 elements along its length. And by changing this bias, I can change where I want the mesh refinement to be. And so I can maybe, so I can mesh that curve. And then that will dictate for this volume where it's putting down mesh fineness on this volume. And maybe what I wanted to do is maybe I wanted to have a lot more refinement around these circles. So I can delete the mesh again. Through the command or through the GUI, that would be under mesh volume, and then this X for delete the mesh. Just select all volumes and delete. Go ahead and specify maybe I want maybe 36 elements around each of these circles. Something that's kind of neat too is if you select entities in Qubit, if you right click, there's this option to select similar curves or surfaces or volumes. And so it'll select kind of similar curves that are similar to it. Here we've it's like maybe a couple extra curves we don't want, but that's just something that's a new feature of Qubit that we're kind of excited about. Probably actually going to need to split these as periodics, my guess, Carl. So let's actually there's a function in Qubit that these are periodic surfaces that sometimes, as you saw, they're not really, you don't really like to have meshes assigned them because it's just like a single closed loop. You can actually remove periodic volume all, or the periodic remove all, I think. Is that the command, Carl? Because this is something that's kind of a useful feature in the command line, is if you type any command and a question mark, it'll give you commands that start with that option, or you could type an ampersand and it'll look for any commands that have it in there. So for this case, this periodic, I can do an ampersand and find where I can split periodic is what I want. And so that's like a useful little feature of Qubit. And so you can see it's now split these circular curves so that I've got multiple surfaces. So this is going to be a little bit better for meshing. I can select these curves again. And then apply my sizing to them. Oops. May still not like these. Anyway, that's just an idea of where we can. Oh, approximate size was 36. I wanted intervals to be 36. That was my issue. And now if I were to mesh the surface, you see I'm going to get a really fine mesh around those features. Something else I want to show too is another example. We can build not just hex meshes, but also tetrahedral meshes and mixed hex tet. So here is a piston model. We have a tet meshing scheme. So if I go mesh, volume, scheme, tet mesh, and mesh a volume with tets. But also, say that I want to have good hex quality mesh or good hex mesh in a certain region I care about, and then the rest of it, I don't care if it's a tet mesh. We could say maybe do a decomposition. So let me decompose a surface here, sweeping a surface. So I'm going to sweep this volume through itself. And maybe I'll even do that for this other surface too. So maybe I really care about the yellow and purple regions for like stress, but I don't care about the rest of my model. Can imprint all, merge all. I can build hex meshes on these two volumes. So I'm going to build two hex meshes for these. Oops. But now this other volume, I don't care if it's a tetrahedra. And if we look at this volume, you can see that it already has quads on that merged surface that it had with the other surfaces. And so if we want to go to a tet mesh, we're going to use pyramid elements to convert between hexahedra to tetrahedra. So for this volume, all I need to do is tell this volume I want to be tet meshed. And it will build a tet mesh that has one layer of pyramids that join to those other volumes. So if I actually draw pyramid, you can see here that one layer of pyramid elements that transition from hexes to tets. And that can be something that can be really helpful for your meshing workflows to be able to still have the value of hexes, but then the speed of creating meshes with tetrahedra. Last thing I want to talk about, just as a background to Qubit, is that Qubit was developed at the national labs at the US Department of Energy. Specifically, let me just make this big again. Specifically to support their DOE codes. And the DOE codes use an open source mesh format. They heavily use this open source mesh format called Exodus. And Qubit was effectively developed to support Exodus natively. And so you'll see terminology from Exodus inside of Qubit, like block, side set, node set. And so those are things that the DOE codes use to assign material properties for or boundary conditions for. And so a block is like a region that you're going to apply a material on, or like a body load on. A side set's maybe what you'll apply like a traction to, or if you want an entire surface, you're going to apply maybe a Dirichlet boundary condition onto, like a zero displacement, and then node sets as well. You can also then use those for like output, but this is terminology you'll see in Qubit. So if we want to build a simulation model, I might want this entire volume to be steel. And so in our GUI, we then have this analysis groups of materials. We can assign blocks. I can say block 1, might give it a name of steel, and choose all volumes. I can then view that block in my model tree. And let me actually, I'm going to switch over. I'm just going to reset this volume so that it's just the, I'm just going to build a tet mesh. So as you can see, this is one of the reasons why I like using the command line as you start to get advanced, because you can avoid a lot of the button clicks you might otherwise do. I'm going to create block 1, call it steel, and then it's going to be this volume. I can create side sets. So maybe I want going to assign maybe like symmetry boundary conditions for my model. So I'm going to create side set 1. Might call this X symmetry. I'm going to assign it a surface for my model. And then in another side set called Z symmetry from these two surfaces. And again, we'll be able to see those in our model. You can then export this mesh to a number of different finite element mesh formats. So like the Exodus format, as well as Abacus input decks, ANSYS CDB, CGNS, Fluent, just a whole list of them, and we're adding more. If there are formats that you would like to see us add functionality for or capabilities for, just send us a note to support@Coreform, and we'll take a look at adding those. But here I could export this to an Exodus file. Call this piston mesh. And I've actually done this for, I kind of alluded to that there are open source codes. One of those open source codes is called FireDrake. And FireDrake can accept an Exodus mesh as an input format. And so I've actually done that, where I've installed FireDrake, and I can actually run, I've built a mesh in Qubit. I'll even show you the journal file that I built for this. I actually wrote in Python. We have a webinar on how to build Python scripts. Let's even open up the journal file. But I have a journal file which runs through and creates this simple mesh that I can then call from FireDrake, run a simulation on, and then view the results in ParaView. And so if you look at solvers, at open source solvers that support the Exodus format or any of these other formats that Qubit supports, it's a way that you can now use Qubit to build meshes for open source codes or your own codes that you're interested in using. But I will say that from a preference standpoint, Exodus is the native mesh format for Qubit, and so that's the one that you're going to have the most success and the most compatibility with other codes for, is if they support Exodus. I think that's about all that I have time for today. Hope this was a useful kind of broad introduction to just some of the different functionalities that Qubit has. From this kind of starting or jumping off point, that we have this slew of other tutorials and webinars. Hopefully this has introduced you to the GUI and some of the general ideas about Qubit that you can then go off and learn more about how to build meshes for your specific problems. But I think what I'd like to do now is just open up to questions if people have them, because I'm sure that there are some questions.
Yes. Greg, we have a question about material model assignment and boundary conditions in Qubit.
Yes. Yeah. Yep. Yeah, so that's a good question. So in this case, the way that we've assigned materials has been through, we're assigning regions, so a block and a disk, that then in our simulation solver, so if I open up this FireDrake input, it's applying, in this case in FireDrake, it's applying the physics on the domain. So this domain 4, in this case, is applied to block ID 4, which is disk. And this is DX3. So this is how FireDrake does it, but we're assigning it to these blocks. And then it assigns boundary conditions, again, in FireDrake at least, by applying them to named side sets. So this tag of 12 correlates to this side set. And then there's a side set for 13, which they're applying a boundary integral across this surface here, or this side set. So that's how, in the general sense, you're going to assign materials through assigning regions of your mesh that then your solver is going to then apply the materials for. So like in Abacus, for instance, you have like element sets, and a certain element set will then there'll be an element card, or sorry, a material card, and then there'll be a section card that then applies a certain material to a certain set. And so you're going to find all of that through assigning these blocks, side sets, and node sets. We do have some basic functionality for assigning materials. We're actually extending this in the future to support more things, but right now we only really support Abacus and a few CFD codes. So we do have the ability to assign like a material, but as you'll notice here, it's kind of a basic material kind of card. It doesn't really have, maybe if you have like a complex concrete fracture model, that functionality doesn't yet exist in Qubit to assign this directly. So what we recommend is assign your regions through block side sets and node sets, and then use your input files in whatever code you're using to reference those sets to apply a condition to. Is that helpful? Yeah, that's a good question. So Qubit, I guess, as a bit more perspective, Qubit has historically been just a meshing program, really trying to focus on orphaned codes that don't have like a native environment for building the meshes or building like the simulation. And so for things like Firedrake or OpenCFS or Phoenix, we're really building a mesh and then creating these sets or subsets within the mesh that then can be referenced by. We are working to build Qubit into more of a full-featured simulation preprocessor that will have more functionality to support those codes where you can actually assign a material directly inside of Qubit and store it as a exportable object for a specific code. But that's not yet something that we've developed inside of Qubit. But that
Greg,
is like in our horizon. Yeah.
we have a question about how to smooth a mesh. This is probably the last question we have time for today.
Sure. Yeah, so that's a great question. So under the command panel for mesh, so depending on, in this case, this is a surface mesh here. I'm gonna go mesh surface. We have functionalities for seeing the quality. So we can choose a quality metric here, which is like this little ribbon. It's like a prize for how good something was. We could choose to look at maybe a scale Jacobian for these surfaces and plot the element quality. And then next to it, there's this iron. So, from using an iron to smooth out clothes, that's where our smoothing operations are held in. And you can then choose different schemes. So we could choose like a Laplacian scheme for these surfaces. We could allow it to freely change the boundary nodes if we want, as well as maybe a tolerance for that Laplacian smoother. So like a super tight tolerance of 1 - 9. We wouldn't want to do this on a large mesh, but on a small mesh, we could do this here. And that's now smoothed our mesh, and we could reevaluate our quality metrics. You can see our worst elements have gone up by about 0.1 unscaled Jacobian. So it's like almost 20% from 0.44 to 0.55. So it's a pretty good smooth there. And we offer that for both surfaces as well as for on volumes. We can do smoothing.
Greg?
Yeah.
Never mind. Go ahead with what you were saying.
Yeah, something else is kind of interesting too. We do have some refinement. You can do local refinement. So you could, as you get more advanced, you can find Python. If you actually find regions that you want to, you could automatically detect and find areas you wanted to refine. But you also select in the GUI. So you could refine a surface. But I might want to refine the surface with one iteration. Let me just reset my refresh my display. So you can see I've refined my mesh here. You could also operate directly on triangles and directly refine some triangles. So maybe I looked at my simulation and I saw that this domain here, there was some interesting physics going on. I want to refine this region. I want to refine it like 3 times or something like that. And so then we can get refined regions for refinement. And typically, if you've done a refinement, you do typically want to come through and then smooth. We might choose to smooth these again. And if I decided this smoothing is taking too long, I can always cancel the smoothing partway through. And it'll stop just wherever it's gotten in this plotting smoothing. So it's just another way that you can do kind of some local refinements if you want. You know, I can do this on a single element here. Oops. General refinement for the single element. And again, this works for quads as well. The key is that when we do refinement, we do conforming refinement. So if I actually reset, if I have like a quad mesh, if you refine a quad, just notice that we're not going to do hanging nodes. We do conformal refinement, as opposed so that there's no hanging nodes anywhere. So no T-junks or anything like that. But yeah.
Greg, can you do refinement between objects?
Yeah, so in this case, we could select like a curve and refine on a curve, or we could do like the surface between objects. So here, since I just have a surface mesh here, I'm just going to show how I could do refinement on a curve. And then it will refine, those quadrilaterals that were touching that curve and like for the depth of those elements. And so if this was a volume, I could have selected the surface that split the two volumes or separated the volumes together, the bounding surfaces. I could say refine all those surfaces, and I would get that mesh. Actually, we can even show that. Let's do 2 bricks here. And let's do merge all. So I can select surface, refine. Something that's interesting is if you click, so wherever my mouse is at, if I click a surface, if I hit tab, it'll actually cycle through all the different surfaces that were behind my mouse for selection. And so that's a way for you to be able to easily, if I want to select like this mid surface here, I could just tab and select that surface. And then we could refine that. And so here's this conformal refinement along that surface between these two objects.
Thank you, Greg.
Yep.
We're out of time. We don't want to keep anyone much longer than the hour that they had scheduled.
Sure. Yeah. Yeah.
Thank you very much for that.
Yeah. And again, what I'll say is that we have a lot of great webinars, I think, on our YouTube page. But if you see something that you'd like to have, or some specific question that you'd like to have like an in-depth discussion about, if you want an in-depth discussion about refinement or an in-depth discussion about scripting or about surface smoothing or any kind of that sort of stuff, let us know and we'll put together a webinar on those topics for you and share them out. So yeah. Just say thanks everyone for your time today.
For those of you who are still here, we would love it if you could answer this final poll to let us know how we did. We're always trying to improve these and make them as useful as possible for all of you. And thank you again so much for attending. Please feel free to visit our forum with any questions that you might have. It's forum.coreform.com. Check out our YouTube channel. And also feel free to reach out to us directly with any questions that you have about Qubit going forward.
Thanks, everyone.
Thank you very much. Have a great day.